before we get into the intelligent lifting device, the ILD, let's talk a little bit about what else is out there that people typically use in material handling. And really the workhorse of the material handling industry is the electric chain hoist. Gore-Bell does have a line of electric chain hoists, and you can see up here, we've got a full line. There are applications where precision and speed that the G-Force can step up and take care of with regards to speed and precision, smoothness, and intelligence features. So without further ado, let me get right into the kind of the demo. So the one thing you'll notice that's different about the G-Force or the intelligent lifting device is when you grab onto this handle, this is what we refer to as a slide handle. I simply engage the product and I move my arm. That's all I'm doing is I move my arm. I don't think about anything else. I'm not thinking about throttling up or throttling down. I'm not thinking about pushing a button. This literally marries with the motion of my body, and it takes very little force to go up or down. There is an operator presence sensor on the back side of this handle, so if I try to move it inadvertently, it won't move. But I can grab onto this and literally just move my hand anywhere I want, as fast or as slow as I want, and it'll move with me. So that is the main difference. And you'll also notice the speed. The speed is much different than electric chain hoist. A typical electric chain hoist speed is about 16 feet a minute, maybe up to 32 feet a minute on a fast one. The G-Force in this capacity, which is 165 pounds, will go up to 200 feet a minute. So you have incredible speed, and then you also have this precision, so you can transition from fast to slow wherever you want. Now, that speed comes about because there's a very different kind of control system and motor in the intelligent lifting device than would be in a standard electric chain hoist. Electric chain hoist uses an induction motor. It's just simply a motor that you apply power to. It's going to spin as fast as it can until you take the button off. You reduce it with gear reduction, but it's a dumb motor. It doesn't know really what it's going on. It knows that you've applied power. It does what it does until you either overload it or you take your hand off the button or disengage power. So a servo motor system is very tightly controlled. It's a type of control and motor system that would be in an arm robot, skater robots, anything like that, any kind of pre-programmed machinery. CNC high precision machining centers use servo motors. So that's what's going to get you that control and that precision that you'll never get out of an electric chain hoist or a non-servo based product. So the other thing that you've got with the G-Force, besides the speed and the precision of what we call run mode. So when I've got my hand engaged on the product and it's moving with me, that's what we call run mode. There's another mode in here called float mode. So what I can do, and I've got really good precision as I showed you, but if I needed to put this piece of bar stock in this horizontal turning machine here, that's just chuck, it would be really good if I could actually put my hands on the product and guide it rather than having to do it from the handle and use two hands maybe. So I can do that with this product, and we'll go into a second control mode called float mode. When I press this button right here, you're going to see a blue light up right here. And now what that does is it puts it into a float mode. Now I can float this product, and I can float it throughout the entire stroke of the G-Force range, which, by the way, full up to full down is about 11 feet standard. So you can go full up to full down, total travel is 11 feet. But now what this allows me to do is actually take and load this piece of bar stock into the chuck, okay? So I can put this right in there, and I guide it right in very easily, and I put it in. So now that would be, if you were to compare that with doing it with, if you could imagine doing that same operation with a chain hoist, what's going to happen is you're going to have the pennant in one hand, and you'll be jogging up, jogging down, trying to get that right position to get this into the chuck like I just did. If you over jog in the up position with the hoist, it's going to go up, and it's going to push upward with the full force of the capacity of that chain hoist. What could happen there is you damage your product, you damage your equipment, right? If I was to over jog in the downward direction, the gravity takes over, and the weight of my part now is jamming that into the machine. The beautiful thing about float mode, besides the actual control that we have, is the fact that when I press on float mode, this is basically weightless, and there's no more weight ever that's going to be on this part or on your machine than you're pressing with your finger, right? So when I put that in, or if I put this on the table, there's no more force underneath here, and I could actually put my finger underneath there. There's no force on my hand other than what I'm pressing on with my finger. So that is a big thing for loading machine centers, any kind of assembly operation. That really works out really, really well. We've added this new feature where we have what we call the Smart Connect user interface. And this Smart Connect user interface is actually wirelessly connected. It could be a wire, but I've got a wireless line of sight connection that I can make to the G-Force, and I can do all kinds of different settings. What I'm going to do here is I'm going to go over to my settings mode here, my settings menu, and under float mode on the screen here, you'll see there's a little tab here that says manual. I'm going to press that, and it's going to change to auto. What that does, if your process is such that you don't want to have your operator having to press the button to transition between run mode and float mode, this mode actually allows you to go back and forth seamlessly. So I can now grab this handle or in run mode, and then without pressing a button, I can actually go right to float mode. I'm going to show you another thing. We're going to get into virtual limits here in a second. So if I were to go full up speed now, and I try to remove this part from the chuck, and I was to take it back out, say I went through a machining cycle, I needed to come in and grab it again. If I went full up, I could potentially maybe put too much force on there. So I can error proof these applications. What I'm going to do is come over here. I'm going to go to my virtual limits tab, and I'm going to enable what's called an upper slowdown. What that does, it allows me, when I go in the upward direction, it's not going to go real fast. So I've got control. I'm not going to bind that. I'm not going to over jog or over when I'm trying to get that part back out. It's not going to bind on me. So I've got that slowdown there. I can also set a hard stop upward or a hard stop downward, or there's some other ones we'll see in 1 second when we pick up the triangle. So I wanted to point that out. So I'm going to go ahead and disconnect this. We're going to pick up our triangle. Let me turn off our upper limit again. So come back over here, disable the upper limit. So now I can actually go free upward and downward. I'm going to come over here. I'm going to pick up the triangle. And this is about, by the way, the weight of this load, the magnet and the bar stock is about 70 pounds. And this is about 45 to 55 pound triangle I've got on the load here, or on the G-force here. So, so we went through auto float. We went through the different virtual limits and everything. As long as we're talking about virtual limits, I did want to show you, we could do error proofing like we did with this upward slowdown here. I'm going to do error proofing in a downward direction, right? So when I've got this triangle attached here, if I were to go down, you can see we talked about before, I've got that real high speed, 200 feet a minute top speed. I can go as fast as I want to go. I can also have my operator has the ability to transition to a very slow speed and be able to go very quickly and then transition to a very slow speed and then set it down on the ground with an incredible amount of finesse and precision. However, there's also operator error, right? There's human error in the equation. So if somebody's not paying attention and they maybe don't slow down quickly enough, they could potentially have the option to impact the floor at a high rate of speed, potentially damaging our product here, right? So what I can do here is, just like I did the upper slowdown over here, I can come over here and I'm going to enable a lower slowdown point. So now if I try to do what I did before and my operator isn't paying attention and they try to go to the floor at full speed, they no longer can because it slows down automatically to a very slow speed and doesn't allow them to do that. So there's some of the intelligence features that allow you to error-proof your process. So what's the benefit of that is reduction in product damage, rework, scrap. And when you're talking about some of the applications that we get involved in with the G-force, like aerospace, machining, high value parts like that, a return on investment based on product damage reduction or reduction in scrap is a very quick ROI typically with applications like that. G-forces will go up to 1,320 pounds in 4 different capacities. So we've got a 165 pound model, which you're seeing here today. We've got another one up from that is 330 pounds, one up from that that's 660 pounds, and the final one at 1,320 pounds. Every unit will lift from 0 all the way up to its full capacity. The G-force does go on a bridge crane, as you see above here, and it's going to give you a lot of coverage area. So you could, a standard Gorbel workstation crane with the G-force is going to give you a lot of coverage area option. But ergonomically speaking, you will see that when I move this around, just like I'm with a hoist, I have to move the weight of the actuator up there, the weight of the hoist or the intelligent lift device itself, and I have to move the manage the inertia and the mass of the bridge. So we have another option, which is very popular, and that's the easy arm. So over here, I'll bring over the easy arm, and you'll see the easy arm is actually what looks like what you see up here on the bridge, riding on the bridge. We actually now take that power unit we call the actuator, and we put that on the top of the mast of the easy arm. Now this is an all-in-one product, so when you say easy arm, you're referring to the entire package. That's the arm, the articulated arm, the mast, and the power unit, the actuator, and the handle all together.